The last part of vector 2 we're going to talk about is reflection of a point about a line. So reflection of a point about a line essentially will require us to find the four perpendicular first, followed by using the midpoint theorem or ratio theorem to find the reflected point. So if I bother to go and draw it out, okay, you're going to look something like this. Let's say this is my point P, this is my line equation, and point of reflection about line essentially should look like this. This is my point P prime, which is a reflected point. Okay, once I'm done, I need to go and find my four perpendicular first. Okay, and you do realize that PF and FP prime, the distance is the same. So by using my ratio theorem, I can see that okay, OF will be equal to OP plus OP prime divided by 2. And by manipulating which is the OP prime I want to find is essentially equal to 2 of OF minus OP. And 2 of OF is 4 perpendicular, which I can find given the point and line. Then using the ratio theorem, manipulate, I should be able to get a point of reflection. Okay, so I'm going to restart doing this entire question again. Okay, so let's say point P is 2, 2, 4, and my line equation is R equal to minus 1, 1, and 2 plus lambda 1, 2, and 2. I'm going to try doing to find the four perpendicular first, followed by finding the reflected point. So first, okay, you have to recall to find the four perpendicular. I can say that since F lies on line, OF will be equal to minus 1 plus lambda, 1 plus 2 lambda, 2 plus 2 lambda, for some lambda is real number. Take note, okay, you have to go and define your OF first. Okay, then what I'm going to do next is, okay, I can see that PF and my line direction is perpendicular. So I'm going to find my PF first. PF will be equal to OF minus OP, which will give me minus 1 plus lambda, 1 plus 2 lambda, 2 plus 2 lambda, minus away my OP, which is 2, 2, and 4, will derive me to add minus 3 plus lambda, minus 1 plus 2 lambda, and minus 2 plus 2 lambda. Okay, from here next, we will learn that PF is perpendicular. So since PF is perpendicular to my line, okay, minus 3 plus lambda, minus 1 plus 2 lambda, minus 2 plus 2 lambda, dot with my direction, which is 1, 2, and 2, will give me 0. Okay, take note, PF perpendicular line, so you take PF dot in my direction will give me 0. Okay, quickly expand out. Minus 2 plus 4 lambda, minus 4 plus 4 lambda will give me 0, and you will derive lambda is equal to 1. So you can derive that OF will be equal to 0, 3, and 4. Okay, once you derive OF, okay, we're going to use our ratio theorem. Okay, so we learned that OF will be equal to OP plus OP prime divided by 2. And OP prime is something that I have to find. So same thing, if the question denote what's your P prime, please go and denote it as well. Okay, so it's equal to 2 of OF minus OP. Okay, I got OF, which is 0, 3, and 4, minus my OP, which is 2, 2, and 4. Okay, quickly expand out. I'll get 0, 6, and 8, minus 2, 2, and 4, which will give me minus 2, 4, and 4. So if I want to write out in coordinate form, then it'll be P prime equal to minus 2, 4, and 4. If you can understand my example over here, do kindly go back to the example on the notes, okay, where I uses a different point and line. Yes, I understand that you already found a four perpendicular and stuff, but it will be a good revision for you to restart the entire thing from scratch. So assuming this is the first time you've seen the point and seen the line, go and learn how to find the four perpendicular first, followed by using the ratio theorem to find the reflected point. Okay, so this will summarize out my entire vector 2